Hi, I'm Kyle with IFixit, and I'm here with Jessa Jones from iPad Rehab, and she has a whole bunch of equipment here she's going to teach us how to use.
Okay.
So I have always wanted to learn more about kind of micro soldering. I've done kind of very crude soldering on my car, on some larger electronics, but never on anything as small as an iPhone.
Yes. So you do need to have sort of, specialty equipment. And really when people kind of want to go from general repair to actually doing micro soldering repairs, investment in quality equipment is the number one thing that I would recommend for success.
Okay.
Because it really helps you to figure out if you're using good equipment to start with, then that sort of lets you sort of know that it's not the equipment problem.
Right.
And then as you kind of build your skills up, then, it's just that much easier. If you start out with equipment that's not working well or is very variable, then it can be really difficult to kind of build your skills.
And that's unintuitive because you start out and you're like, well, I don't know if I'm going to do this.
Right.
I'm just going to buy the cheapest tool and see if it works.
Right.
And then you fail and you feel like it's your fault. And
right.
So it might be better to try to borrow some good equipment from somebody before
really,
you invest.
It really is. And this stuff has like a really excellent resale value, so you can kind of go to the used marketplace and kind of pick something up, try it. If it's not for you, sell it, I mean, it really is worth it to start with the good stuff.
Sounds good. So what do we have here?
Okay, so let's start with the common tool, the soldering iron. So this is this blue and yellow stuff is all Hako branded.
So this is the soldering iron base station.
Yep, so that's the station, and this one is a dual port station, so I can plug in two different tools here. So it is the FM203, and that's what I use, every day in my mail and repair business. And I can use it to power one of these hand tools. This is a just standard iron, and with your standard iron, you can get a variety of different tips. So we can kind of look under the microscope actually to see.
Okay. So that's your like normal everyday tip that you've got on.
Oops. This tip is good for certain things. It's a little bit small. It's a chisel tip.
Okay.
And I can
so it's
use
a little
that.
bit rounded at the end.
Yeah, I can use this for kind of some standard desoldering. It would be a great size right here for this connector. Okay. If I was soldering on a connector onto this board, something like that. But
it's a lot smaller than a typical soldering iron.
Yes, it's a lot smaller than this. This is a typical soldering iron that does not go with this station.
Okay.
And if we kind of look at that.
That's just the one from our teardown workshop.
Yes. Well,
so you can see that's a lot larger.
Right. So that's a much bigger tip, and that would. Okay. And that's okay. You want to have the sort of the right size tip for each job, and that's going to kind of be a trade-off between how much heat you need to transfer to that component in the board versus your clearance. Especially when you're working on cell phones. The clearances are really, really tight. So that's why you kind of need really good tools that can deliver a lot of heat in a really tiny tip.
So what's the difference between a cheap soldering iron and a Hako? Is it how quickly it reheats?
Part of it, yep. I mean, you heard the sort of beep when we plug that in. So your Hako station is going to just heat up your tip really quickly. You can switch between tips really, really quickly. If you're using sort of your inexpensive iron, it's going to heat up to maybe not the same temperature all the time. It's going to take a long time. Okay. And it's, you'll just sort of notice in the kind of the feel of how quickly it heats up, how reliably it heats up, and what it feels like when you're actually soldering on the board.
Got it. So they'll both heat up, but this maybe allows you to switch tools a little faster.
Yes, and that's something that you definitely want to do. So we've got a couple other hand pieces here. This is my favorite tool, and I think I use this for 90% of what I do. These are called the Hako Mini Hot Tweezers FM2023, and they come. So it's
like a tweezer.
It is
kind of like my tweezer here.
Exactly.
But it will burn you.
Right. So this is great if you just kind of really think about the actual kind of physical job of taking off a small component that's on the board, like a capacitor or a filter or resistor that's soldered on two pads. Being able to sort of heat both pads and pinch it off is great. As opposed to just sort of trying to hit one side and the other side, one side and the other side. It's easy to see.
So if you've got something with 4 pads, would you melt 2 and like lift it off a little and then do the next 2?
I can show you an example of that when we kind of start actually doing some soldering. But you could just sort of kind of go across or down the connector like this kind of spot here on the board. If I was desoldering, here I could just sort of pinch and go down that connector like that.
Okay.
I don't know if you guys can see that.
Yeah, that makes sense.
I could.
So you're just in a swiping motion, you're desoldering
Exactly,
as you
something
go.
like that. Right.
And
Now
so it's
what-
nice you have 2 contact points instead of just one.
Yes, and what's the other reason that I like this tool, and not everybody does. One thing I've noticed in the microsoldering community is that everybody kind of gets their own style, you know, and so you do sort of want to just try things and see what works for you. The reason I like this tool is because I can, you know, kind of come in here and just use one side of it, one side of tweezers,
Okay.
or I could put them together.
And get twice as much
And then I would
heat.
have, yes, twice as much heat. And you'll notice when we start soldering that the thermal mass of the workpiece is really different, even on different pads.
Okay.
And we'll look at that when we look at one of these sort of S3 charge port boards.
So it's
it really
like
does make a
welding.
difference.
If you're welding a different material, I mean, the thickness of the material completely changes
It does.
how
yes.
it flows.
Right. And
Okay.
that's like one of the things people struggle with, you know, like you kind of assume if you look at, you know, like a bunch of pads in a row, you'll assume that, you know, you can just, if I can hit this one and it flows and hit the next one and it flows, why isn't it flowing on the third one? And the answer is because, well, that one's probably connected to ground
It's
or
through
something.
via the ground or
Yeah, so where it's
okay.
like just going to suck up so much heat, you know, and then that's one of the sort of, you know, problems that we'll kind of teach you how to deal with in our little soldering series here.
Got it.
Okay, so, and then another tool that I use a lot is the tiniest thing that you can get, which is the micro pencil. So this is another Hako product, and it's another handpiece. It could also plug into my...
So it's just a smaller soldering iron.
Yes, it's
it's
the
about-
tiniest thing. It's 0.1 millimeter tip.
Okay.
And, you know, one of the things that I've kind of learned to do...
That's about the size of our pentalobe driver. Right at the end of that.
Yeah.
Okay.
And then you can see that it's no longer like perfectly round. I have filed this tip. Let's see if I can kind of rotate it for you a little bit, maybe. So I actually
you'll take
love these
something.
things. Yeah, that's exactly what I use.
Okay.
The
So this is our
tweet-
iFixit
Yeah, file set.
file set. All right.
Yep. So, you know, what solder loves is copper.
Okay.
And solder also loves heat. So if you look at a tip, you know, even a tip that's like this one here, where is this tip hottest? Close to the very bottom end of it, or sort of back
Probably
up here?
back up there.
Yeah, exactly. So if I were to dip this thing in solder, the
solder
solder would sort of
will
flow
migrate
up here,
up.
right? And if I'm trying to, like, you know, make the tip work, it's a struggle, right? So one sort of strategy that you can use is you can actually file, you know, like I just sort of start filing right there, and I can actually kind of expose a little bit of the copper core,
Okay.
and that will help the solder to stay right at the very end. It does shorten your tip life, but it can really help you sort of create that perfect shape with the perfect flow so that you can do the tiniest of stuff, like the 5S blue screen of death trace repair,
Okay.
where you've got 7 traces
And
that
they're
are all in the
super next to each
size,
other.
you know,
Okay.
the size of, like, you know, a millimeter square box.
Okay.
And you got to
Get in there.
get those guys tacked down without lifting the other ones, you know, then this is the go-to tool for that.
Okay. Fantastic.
All right, so now let's talk about solder itself. So,
So we've got our soldering iron. We've got our this is a pencil.
Yep,
size
micro
soldering-
pencil, yep.
Micro pencil. We've got our hot tweezers.
yep,
And now we're going to take a look at our ammunition. As it
yes, exactly. So, so solder comes in different flavors. And, you know, this is something where, you know, there's sort of my approach to microsoldering is practical microsoldering, what practically makes sense. And that might be a little bit different than sort of industrial manufacturing and what makes sense to make sort of the, you know, the perfect, most sort of certifiable strong joint, you know, that meets the requirements to the letter of the law. So if you take any board, you know, like this is a Samsung S3 board, the new regulations say that they can't use the good stuff. The good
They
stuff.
can't use lead.
They can't use this, you know, leaded, old school solder. They have to use the lead-free. And lead-free is, you know, it's kind of like a square peg in a round hole. You know, it's just difficult.
It works, but it's much harder to work with.
Right,
All the
exactly.
electronics manufacturers have a really hard time shifting
Right.
to lead-free solder. The military electronics manufacturers still use lead-based solder because they're
The
exempt
military.
from the regulations.
That's right.
So where it's legal to do it, everybody uses leaded solder.
Right, yeah.
So when you're doing your work, you prefer to use the low melt.
When
low
I do
melt
my work,
solder.
I use leaded solder because what I care about is getting the device back on the road. I don't care about the device, you know, going to sort of survive a trip on the space shuttle. You know, like
Sure.
I care about somebody's iPhone turning back on so that they can continue to play Candy Crush. That's what I care about.
Okay.
So
So maybe when you're done, you wash your hands.
yeah, and I don't lick it, you know,
Okay.
and I don't let my kids lick it, you know.
Okay.
I mean, that's I mean, safety has no quitting time.
All right. Okay.
All right.
Got
So
it.
now,
So don't eat the solder.
yes. So lead-free solder, that's the stuff that's on there. So we are kind of working with that, you know, because that's what's already on there. And this has a higher melting temperature. So it's going to take more heat to flow a lead-free joint. It's going to take something, you know, to the tune of like 217 degrees of heat in order to get this stuff to flow.
10-base solder.
So then
Okay.
leaded solder is going to have a lower melting temperature. And that's going to help us if we, you know, are trying to flow like a difficult joint that maybe does have a high thermal mass with a tiny clearance, so we can only use a tiny tip. You know, then by adding the leaded solder, that sort of makes an alloy and it brings down the melting temperature of the joint.
Okay.
And then to go even one step further is this stuff.
So what's the melting temperature on this?
That's like 185 or so,
Okay.
183 if it's the 6337, you know,
Okay.
leaded solder.
All right. And then you've got this for extreme situations.
Yeah, and this is called removal alloy or low melt solder.
Okay.
So this is this is like, I think it's bismuth mixed in, so it's an alloy. And if you mix this into the joint, it'll really bring down the melting temperature of the whole joint to something like, you know, 137, 138.
Okay.
Something
That's
like that.
very low.
It is very low.
Bismuth is expensive, though.
Yes, it is. Yeah, so this is like, you know, $50 worth of stuff. So you only use a little bit. And, you know, if you think about that joint, it's really not very strong at 138 degrees. And so you use this to sort of remove a component, but then you have to remove this in order to be able to place a new component.
Okay.
So how do you remove solder? Solder loves heat and copper.
Copper.
Yes.
So this is copper braid.
Yes, so we've got copper braid, and we can use heat.
And I've
plus
definitely
copper
used this
braid.
before, and it's just amazing. It's like water flowing uphill.
Yes,
It just decides to migrate onto it.
that's right. Yeah, and solder loves copper, solder loves heat. So if you give it heat and copper, that's where it's going to go.
Okay.
Yep. So you can use this to sort of replace whatever solder is on the board. So you can kind of change lead-free to leaded. You can change your removal alloy, your low melt to regular or whatever using braid.
And these always come in a roll, but you can cut off whatever length is convenient for your workspace, and it's not crazy expensive, so
Yes.
you can use a lot of it.
Yes. Now let's talk about what solder hates.
Okay.
So it loves copper, but it hates oxidation. So oxidation is like kind of the biggest problem in making a joint. And oxidation is sort of always present, you know. Even if you have your tip is free from oxidation because you always sort of keep a little bit of solder on it and you replace that every time you use it, there's still going to be a little bit of oxidation there.
And the moment you expose any alloy to air, instantly it starts
There's
oxidizing.
oxygen in the air, and heat, you know, speeds everything up. So something that's hot is going to get sort of this layer of oxide on it. Something that's been sitting around, you know, something that even, you know, if it has been exposed to water, whoa, that's a lot of oxidation. You know?
Yes. So any water damaged board, you're gonna have a hard time soldering on it until you
Yes, in
completely
general,
clean the
right?
oxidation
Yeah.
off.
So
Okay.
so every joint that you make, you have to kind of get rid of oxidation in order to be able to make the joint, you know, at all. And the magical tool that gets rid of oxidation is flux.
Okay.
So flux is the stuff that we use is made of rosin, which comes from, I think, pine trees or something.
Okay.
And
I mean, this looks like you're about to
inject somebody?
Yeah.
It's good for you, Kyle.
Or you're basing a turkey or something.
Yes.
Okay. So I've never seen flux in a
syringe?
syringe like that before.
Yeah, yep. Well, you know, it helps you really kind of place it exactly where you want it to go. Now, flux itself can be corrosive over time. So, you know, even though this stuff is sort of no clean tacky flux, you still, you know, you apply it in order to remove the oxide from the joint.
Okay.
And it's almost like you're preventing oxygen from getting into the joint while you're soldering.
Got it.
Because it itself is a sort of, you know,
It's
tacky
like a liquid
substance.
seal
Yeah,
around
exactly.
your work.
Right,
Okay.
exactly. Same thing. Here's a tip for Thanksgiving. I know your wife is a chef, so she probably already knows this. But if you take potatoes and you chop them up, they'll turn brown.
Right. So stick them in
That
water.
reaction it requires oxygen.
Yes.
So if you know, of course, it's your job to peel potatoes before Thanksgiving.
Yep.
So if you peel them all and you put them under water,
Yep.
you can leave them you can leave them out overnight and they're not going to turn brown.
Same thing with guacamole.
Yeah, exactly. Yeah. So you just sort of deprive it of oxygen. Same
All
thing
right.
going on with the flux
So
solder
keep
joint.
oxygen off of the joint as you're
Exactly. So flux does a great job of removing oxidation from the joint and then preventing it from reoxidizing while you're soldering it. And it helps it's just sort of like a magical substance that just helps the solder to flow and make a good joint, which means the molecules of the solder actually forming an alloy with the copper to make that strong joint that's going to last.
Okay.
So flux is absolutely required. And when we were talking at our practical board repair school of all these sort of funny T-shirt slogan ideas, and one of them was just add more flux.
Add more flux. Okay. So you've been using this microscope here, and we've got the camera on the microscope.
Yes.
Explain to me a little bit about what's different about this microscope.
Okay, so microscope is essential for micro soldering. So when you're on this scale, you really need to have a microscope. What I like about this particular microscope, this is an Amscope. There are other similar brands. I like this one because it has a variable magnification. So some of the microscopes just sort of have, one stop or the other, either 10x or 30x.
Right.
So this is extremely useful, and I use this all the time to sort of adjust, where I'm looking at a joint. This has a double boom stand, which gives it a lot of stability, but it does make it sort of a little bit more difficult to sort of raise and lower. Like I can see from that image that we need to adjust our
Height a little bit to get the
height
focus.
a little bit to get that.
The focus is all about what your distance is from the working surface.
Yes. So working distance, that's also going to be kind of,
So you have enough room to get your
variable.
hands under there.
And your soldering iron, exactly. Yes.
Got it.
So here we go. Let's try to crisp that up a little bit. That looks a little bit better.
Yeah. Well, this is great. So these are all of the tools that you need to get into micro soldering.
Yes. Flux, solder, quality soldering iron, and then you're really going to help yourself out if you avoid getting cancer. So you're going to use a fume extractor because the flux burns off. It's not really the solder, and you're not really inhaling lead, but the flux fumes can cause like an occupational asthma. So if you're going to be doing this every day, you need to invest in at least one of those kind of like, smoke absorber, if not a full sort of fume extraction kit. And then the other thing that's really going to help you out that we didn't talk about is the source of hot air. So hot air, or a rework station, which will allow you to shoot out hot air very quickly if it's a quality brand, very reliably if it's a quality brand. It will allow you to shoot out hot air that will enable you to do repairs that you can't do with just a soldering iron. For example, if you wanted to sort of remove a bigger chip, like a MacBook board, where you need to sort of replace
something where you need to
big IC.
heat a lot of things at once.
Right,
and
exactly.
Moving the soldering iron from one trace to another would
Right,
take too
like
long.
at one of the sort of like a big chip like that, on the board.
Okay.
If I could remove something like that.
So that's
with heat.
often I'll see people and they've got the tweezers and they've got the hot air station and okay.
Yes. Yep. So hot
So
air
this is maybe start with a soldering iron and work your way up to a rework station
Right.
if you're doing more.
Yep. Or hot air, some people use hot air sort of in general because hot air itself, remember that, a component is going to go to, solder sort of likes solder, it likes copper. So if you put hot air, heat on it, it's going to sort of move by itself to its pads and make a good connection. So some people solder like exclusively with hot air.
Yes, and it can work really well. All right, so we have all of our tools here, and we have a bare board. So this is like a bare board in the iPhone factory.
Right.
Board's coming along, and then they would use a pick and place robot to place everything.
Right.
But we don't have a robot, so we're going to do it ourselves.
Right. Yep. It's a great place to practice when you first kind of get your equipment and you're excited to try it out, and you kind of want something to work on. It's hard to find things that are really on this scale, super tiny, micro scale. So this is a good thing to buy. These boards are not expensive, and we can just kind of try to replace the digitizer connector. So what I have here is a iPhone
Okay.
5S actual digitizer connector that you'd snap your screen into, and we're going to try to place it on this bare board. So all of the yellow dots on the board, that's all the exposed copper. And if we kind of really look at this board, we can get a lot of information. You can see that these are called pads, and they're made of copper, so they're going to love solder. But the whole thing is covered with a mask. Here you can see I'm kind of scraping that here a little bit.
Yeah, so you can see the copper.
So the whole thing is copper, but it's coated with a conformal coating that protects the parts of the board that we don't want to solder to. So we kind of have to sort of keep that in mind as we're working. All right, so now the first step is to apply flux. And what is flux going to do?
Flux prevents oxidation.
That's right, and it's going to take
so
away any sort of
air
oxidation
from
that's sort of already on there.
Okay.
And just sort of in general, all soldering I ever do starts with flux. Add more flux when you're having trouble.
Okay.
All right, now we're going to, before we attempt to place the connector, we're going to tin the pad. So that means we're going to put a little layer of solder on all of these pads. And I'm going to use the mini hot tweezers because they're my fave. So I'm going to tin the pads.
So you're just taking a little bit of solder.
Yep, so I've got a little bit of solder and I'm just sort of going to touch it to the tip. And this is pretty easy.
Just working
I'm
your way
just
along.
going to touch the...
And it's just kind of a sideways motion.
Yeah, I'm just touching it very briefly. I could even do...
So you're
put on
putting
a
the
little bit
solder
more and
onto
just
the
roll
tweezers.
it on here.
Okay.
Like that, exactly. Whoops, I just lost a pad. That's okay. Then we're just going to...
And are you adding the solder to the tweezers themselves and then it rolls down onto the pad?
That's a really good question. Ideally, you're trained to not do that, to not put the solder on the tweezers, and to instead to first, ideally put the hot tweezer, near a pad, and then touch the solder and do it like that.
Okay.
However, the reason why you're going to try to do it that way is because this solder has flux inside it. And if I kind of tin it over here, you can see that the flux sort of, burns away.
Right.
And that's sort of, and now it's just kind of sitting there oxidizing. You can actually see it. If I look, just at that tip now under the microscope, does that look, like it's ready to make a nice, beautiful joint? No, it's all like oxidized and black, right? So in practice, though, at this scale, and this is a part, again, where it's sort of practical microsoldering. In practice, you really can't, at this tiny little scale, really keep your, hot iron over here and kind of touch the joint and feed the solder into it, So in practice, what you end up doing is just kind of being, quick about it, and you can just kind of, like I'm doing right now. I'm touching those pads to flow them, and then every now and then I will clean off using, some copper wire.
Got it.
To clean the oxidized solder off and kind of start over.
Okay.
And then if I feel like this board is, doesn't have enough flux, I can add more flux. If my flux begins to get gummy, I can replace it by cleaning it off with alcohol. And you can just sort of tin these pads, just like I did. Now, a lot of times you'll get into this situation like right here. So here, we have a problem where there's a pad that has lifted. And this is probably, like a good example of, well, geez, now what are you going to do?
Now you're stuck.
Now you're
I
out
broke
of luck.
it. I broke the phone.
I'm going to have to buy this guy a new 5S. Good thing it was only a $1 board. So I can try to stick this sucker back down. And if I can't, that's okay, because I can just make a little jumper ultimately.
Okay.
Yeah, I can kind of nudge it back into place.
So now it's back. All right.
Now it's fine. And I just need to make sure that it's sort of electrically sound. And it is, you know, it kind of goes to this trace here.
Okay.
And that's fine.
Great.
Okay. So now I'm going to use some alcohol and clean off
All the flux.
Yes, because now that flux is kind of getting gummy. And I'm just going to...
So flux will kind of dry out over time.
Yeah, it kind of, you know, it will, as it sort of gets heated, it will turn, like the liquid part of it will evaporate off and it will just sort of leave behind the solid part of it. So it turns like a gummy, viscous stuff.
So use alcohol and then we're cleaning it off. And now is the solder going to start oxidizing then immediately as soon as we...
Well, that's okay because we'll be using flux again, but you know, it's not going to sort of, you know, we're not like counting the stopwatch.
It's not going to oxidize as fast.
Right. It's not going to be something that we have to kind of like worry about the stopwatch. Now, for this actual job that we're doing, which is a connector placement, the thing that we do kind of care about is, are these pads even? You know, because what do you think would happen if one of them kind of had like a little mountain of solder when we go to try to place the connector?
The connector will sit off skew.
Yeah, exactly. Right. Okay. So that's sort of what we care about. So let's inspect, you know, so we can kind of inspect these joints. And, you know, this is a great use for hot air. Okay. Because hot air is really great at kind of, you know, being a tool that will sort of flow all these joints at once. I can put a little bit of flux, fresh flux across here. We can turn this back on. And this is also a great way to learn how to use your hot air station, because you want to kind of, you know, one of the questions I get a lot is, what temperature are you setting that at in order to do this repair? Right. And the answer is 7. You know? Right. So, you know, you want to kind of
well, it's going to be how long you're holding it on the surface, not...
Right. Yeah, it's how far you are. Right. It's the size of your nozzle. You know, this is a 4mm nozzle. If it was the 2 or the 6, it would be completely different. Right. So whatever I set the station at kind of doesn't matter, you know. So you, like with your station that you're going to be using, it's kind of like your, you know, your new BFF. You just have to kind of go on a couple dates. Sure. And you want to just sort of learn how it behaves in your hands, you know. Okay. So in this one, a good way to do that is to do something like we're going to do here, which is to just beat up some pads. So I've got some flux on here. Now when I just sort of apply hot air, we can watch and see what happens.
So they should melt and kind of even themselves out.
Yes, even themselves out, exactly. Let's pay attention to this bottom one down here. Let's see if you guys can see. So this one right there, that's a little uneven. Okay. So let's see what happens. You know, and I can see how the flux is sort of blowing off this board a little bit faster than I'd like. So I'm going to turn the flow down a little bit.
So you have both flow and temperature.
Yes.
So we can say we want to blow less, hotter air.
Yes, exactly.
Okay.
Yep. And then I can apply that and just sort of watch me burn up your magnet board. Oh, there it goes.
There it goes.
Did you see
so
that?
it just kind of.
Yeah.
That's
perfect.
great.
And now it's nice and even.
There we go.
So we're ready to go. So I'll try not to burn you up.
So we have a freshly tinned board now. We have put solder evenly across all of them. We use the rework station to even out some of the kind of
to beat up our pads.
Okay, great. So now they should be all nice and
ready. Exactly. Yes.
Ready and relatively flush or relatively tall, you know, distance off the board.
Yep.
Okay.
So we can kind of see just sort of how that looks pretty good. And
as we go, we're exposing some of the copper on the board, and that's okay.
That's okay. You know, I think that you know, when you're sort of working with a board that has already been tinned, like a, you know, like an actual board, you know, then you're not going to be sort of like tinning these pads. Then you won't see sort of that, you won't see that solder mask come off so easily. Okay. You know, but it's okay. All right. So now it's time to actually place the connector. So I'm going to stick that guy on there. And I'm using 2 tweezers. That gives me a lot of control. And I'm just and I'm looking at it under the microscope, and I'm going to ultimately just try to line it up to sit on those pads, and then I'm going to hold it in place with the tweezers.
So this is the part that takes some patience.
Yeah.
You can do it. You will get it there.
Yeah.
You just got to keep...
Now here you could say, well, why don't you use hot air then? It'll just sort of go into place magically by itself. And you could do that, except this guy's made out of plastic.
And the hot air will melt it.
Exactly.
We run into that problem repairing iPads all the time, where you're trying to heat up the other frame, and you have the home button, and it's made of plastic. And if you heat it up too much, you melt the home button.
Right. So hot air in general, you can do it, but it's really easy to sort of mess up the plastic of the connector. All right.
It looks like it's kind of bumping along.
Yeah, something's bumpy there. So I'm applying quite a bit of pressure there at the top.
Okay.
I don't know if that's the top for you guys or not. It's the bottom for you guys. Up. And then I'm going to just go ahead and flow that pad once I get it on there. I'm missing my other hand now.
So this is like the first
Tacking
the first
it down.
tack.
There we go.
So this is like a welding tack. The first one will kind of hold it in place.
Yes.
And then you can let go.
And now I'm going to go down to the opposite side.
Okay, so now we're kind of pivoting around that first joint. Okay, now we get our second tack on. And once we get that, you should be able to lift the tweezers and
Yeah.
it'll be in place.
Yeah, so that's
There we go.
reasonably aligned for me.
Okay.
So I'm going to take some solder and hold it in the tweezer.
Okay.
And then I'm just going to kind of go down the row. So I'm holding some solder here in the tweezer, and I'm just going to flow those joints.
So we're working our way through, and just one at a time. And so you can see the solder go onto the is a pad the wire on the connector?
It's pad and pin.
Pin.
So
Okay.
the pad is the bottom, and so each pin flows.
So as
and
you
makes
touch
the
it, the solder is flowing upstream, up onto the pen,
Yes.
off of the pad.
Yep.
Okay.
And now we're sort of at our, problem pad. So this one we want to really pay attention to. And that's where it's nice to have the variable, like zoomable magnification.
Wow, yeah, you can really see that.
Yeah, you can totally really see that. And also I think it probably helps this camera because it has less light. So I'm going to sort of
Sure.
move that pad, and it makes the contrast a little bit better.
So you moved it with the tweezers.
I moved it with my regular tweezers,
Okay.
just to make sure, because I want to just kind of make sure that this ends up being a good joint. And a lot of this is just sort of like having common problems and then figuring out solutions to those problems.
Well, that's where the more that you can practice with something that isn't your actual repair,
Yeah, exactly.
the easier it will be.
Yeah, and just there's no substitute for just sort of time in the seat here with this stuff, And you're just going to make every joint. And it's, it doesn't take a lot. You don't want to sort of go up on top of the connector. If you have a connector, another problem you might have is that the connector is misseated a little bit, or it's a little bit high or a little bit low. And then you can use the cold tweezers to sort of press down on the pin. I'm flipping this around to do the other side. And that will help it make a good joint. So we're going to do the other side exactly the same. I'm going to check and sort of say, is my flux like too gummy? Do I have enough? And I think the answer is it's not too gummy, and I do have enough, so I can continue on. If I've been struggling with it for a while, then I might want to just get some alcohol, replace all of that flux. I can look at my tip. Does my tip look healthy right now? It pretty much does. It's silver. So I can just kind of continue on. If my tip looked burnt up, I would, go kind of clean it off. And you're really just kind of flowing the, tinned pads. So you don't really need to add big globs of new solder. So like here, like you can kind of learn like what the ideal joint would look like. You don't want it to be starved for solder, but you also don't want it to be, kind of overloaded either. So this one looks a little bit light. There, now it looks
So we'll
perfect.
just add a bit more. Okay.
Yep.
If you need a bit more solder, just add the solder to your tip, and then it'll transfer it to the
Yeah,
copper.
and you can start to see how my tip is starting to look black now, so I would probably want to clean it off pretty soon. When you get to the ends, these are your anchors. So these you want to build up a little bit. This is the strength for your connector. A lot of times you can, make a perfectly fine connector, but those anchor pins are kind of weak, and then it'll just rip right off when you're plugging in your screen, and that's a big drag.
Okay.
All right, next is inspection. So what makes what's going to give us confidence in this connector is seeing that there's no movement of any of the pins on the pad. And we're also going to kind of turn the board on its side, and that's another great thing about a microscope, that you can kind of have that extra control over, that
Right.
you'll be able to
You can really choose where you
zoom
want to
in,
zoom
and I can
and set
kind of like
specific focus.
adjust the focus and you can kind of go
So you can
through.
really see that there's no gaps on any of the joints.
Yep, and you'll probably find a bad one that you're like, oh, that one I need to sort of reflow. I'm just sort of touching
So you're
each one,
touching them to see
testing
if
it,
they move.
looking for movement.
Okay.
No movement.
And this level of meticulous care about each connector is something at manufacturing they would never do.
Right.
But we have a board, it's worth several $100s.
Right.
Little tiny component has failed, so we're able to
Right.
put a new component on.
Right. I mean, the reality is, if you were going to do this as a board level repair for your general repair business, this is a very typical repair where somebody has, let's say they were troubleshooting a defective screen. So there was a lot of disconnect on it. And, a lot of times those connectors can kind of get shifted a little bit, and it'll mash up the end of it. And then you'll have a screen with no touch.
Okay.
So replacing this connector is a, very valid and viable repair that any general repair shop should be able to do. It's really not that much of a stretch to get this board, get some connectors, practice with good equipment,
Right.
and then you'll be able to do it. You really will.
Well, thank you so much for showing me this. This is absolutely enlightening. This opens up new world of possibilities for repairing very small components. I think this is something that a lot of people could get really into.
Yeah.
So we are going to continue on with this series. We have Jessa Jones here with us all week, and we're going to be doing a number of other repairs.
Yes.
So we'll be diving in, and you're actually going to teach some of us at IFixit how to get in and do some of these repairs.
Yeah, we're going to fix some stuff.
All right.
Yes.